Ishita Singh. 100. Brilliant. Sharma. Aditya Mane. Aditya Mane. Rahul. Isha Rahul. देखो एक बार चेक करो. Isha Rahul. CBSE.
CBSE. Good evening, everybody. Please sit down. Okay. So let us say, for example, we have a plane surface like this. Now this plane surface is, let's say, plane mirror. Okay. So what kind of a surface is it? Plane surface. So mirror has a highly polished glass surface on one side. So how is it? Highly polished. Even a board is highly polished. Okay, so not necessarily glass, any polish. But how is mirror different? The other side is silver coated. So this ensures maximum reflection. Because if you polish and polish and polish, then you might start seeing your face in it. So that's the property of a polished surface, that it reflects maximum light back into the medium from where the light came or was incident on it. So there are two things. One is the incident medium. Incident medium. What is incident medium? The light traveled in that medium before finally hitting the surface. That is called incident medium. Okay. And what do we call this surface as? We call it as reflecting surface. What do we call it as? Reflecting surface. Okay. So now, how the reflection takes place? It is governed according to some law. Reflection of light takes place according to a law. That law is called as law of reflection. Okay? So there are two parts in that law. The first is angle of incidence is equal to angle of reflection. This is the first part of the law. So what is angle of incidence? Angle of incidence is, yes? Yes. So to know what is angle of incidence, you need a normal. And normal is, let's say this is the point where you are going to observe the reflection. So perpendicular drop at a point where reflection is taking place. So this is a normal, it's a perpendicular, and this has to be a dotted line. What is the meaning of a dotted line? It is imaginary. It is not a real light. Okay. So incident ray is, let us say now light is incident like this at this point. Let's call this point as O. So light ray. What is a ray? Ray is nothing but path of light. What is it? Path of light. But generally, light travels in a group of lot of rays. That is called as beam. Okay. But for simplicity, we will talk about ray only. Okay. So this angle between the incident ray and normal is called angle of incidence. Okay. Let's name this ray as AO. So according to this law, then this light will be reflected like this. And this will be called as angle of reflection. Both have to be same as per the law. Okay. So this can be very easily verified. There are experiments. Okay. So which I'll explain further. But this is what is the process of reflection. And this is one part of law of reflection. What is the next part? Do I need to elaborate it? Angle of incidence is equal to angle. You understand, right? Now, what is the second part of the law?
The incident point, normal.
The incident ray. See the diagram. The incident ray, the reflected ray.
And the normal ray are the same.
So this is A dash, and the normal at the point of incidence lie in the same plane. Okay, now what does it mean? Can anybody explain? So let's say this is the plane. Can anybody explain? What does it mean? So what is the law? The incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. Lie in the same plane. Let me demonstrate. Okay. Who has signed on? Okay. So is everybody able to see this? Now imagine this is your reflecting surface, okay? And this is one plane, right? So what it means is, imagine my hand is the reflecting surface. The point of incidence is somewhere here. So if this is the plane, incident rays coming like this, and the reflected rays reflected in the same plane of the node. Okay. Now if I turn it like this, okay. So now the incident ray and the reflected ray is in the same plane. Can you see? Yes. This is what it is. Okay, if you rotate it by 360 degree, so the incident, the plane in which the ray is incident, it will be reflected in the same plane. It can't be incident in this plane and reflected in this plane. No, that's not possible. Okay. Online student, everybody understood? What is the meaning?
Yes, sir.
Second part of the law? Okay. All right. So what we are seeing just now is called regular reflection. Regular reflection. So all plane surfaces, okay. So if there is another incident ray, right, let us say at this point, then all the reflected rays also will be parallel to each other. Incident rays are parallel, reflected rays are also parallel. Okay. So angle of incidence and angle of reflection will be same for all the rays. That kind of reflection is regular reflection. And the plane surface therefore is also called as regular surface, right? So all plane surfaces will cause regular reflection. Oh, yes. Now let us understand what is irregular reflection. Now if you look at wall, is it as smooth as glass? Yeah. So because it has a lot of irregularity, it will not be like even. So when the light is reflected by such surfaces, the reflected rays are not parallel to each other. Okay. I erased it without asking. Is it okay? You had written it? You had not written it? So you should have stopped me. But anyway, do you understand whatever I have taught? It is there in the notes also. Okay? Everything is there in the notes. Okay. What is irregular reflection? It is caused by irregular surfaces or polished. Okay, such as wall or hill. हिल में साउंड के केस में ज्यादा appropriate होगा wall कर लो सब wall or even this laminate table yes table top we should pick examples which are easy to comprehend sound के केस में hill चल जाएगा but light के केस में we don't need hill as an example of irregular surface okay so these surfaces will have so many ups and downs, something like this. Okay. इसको अगर तुम glass से देखोगे तो it will have cavities, peaks, dips, all of those, right? Now let us choose some points. One point is this, then you have this, and then you have this point. Okay. Let's call ABC. So incident rays all will be what direction? Same direction. Isn't it? Yes. These are your incident ray. Now you need to draw reflected ray. So to draw a reflected ray, what you need to draw first? The normal. Okay. Now for a plane surface, normal is perpendicular at that point. What about a curved surface? What is the normal? It's not perpendicular. So what is it? What is a normal on a curved surface? This is a curved surface, right? This is almost a plane surface. So you can take a normal like a normal perpendicular. Because this is irregular, some part of it could be straight also. Okay, so I just dropped a normal. This will be my angle of incidence. So angle of reflection will be equal to I. This is my angle of reflection. Let's call this 1 dash. This is the second ray, this is the third ray. Now, if you look at this surface, this is like curved. This has a curvature, something like this. This is a curved surface, right? So if you come, this curved surface must be part of some sphere, right? So what is the normal for a sphere? It is the radius of the sphere. You always take the radius of the sphere as the normal for the curve. Why it is so? Because if I draw a tangent over here, it will be perpendicular to the radius. Okay? So every curved surface ka normal is the radius. So you complete the curvature. It is the curvature or part of some sphere. So you imagine that. So that radius is the normal. Clear? So if the curvature is like this, so radius will be this side, right? But if the curvature is like this, now how do I keep on this? If the curvature is this, where is the radius here? Okay, so you extend the radius outwards. So for this, the radius is somewhere. Where is the radius here? Down. So you will, ये वाला जो नीचे आ रहा था, you just take it out. Okay, extend it outwards. So now here, this is I. So this will be, this is 2 dash, this is I. This will be. So you can say I1, I2, I3 and R1, R2, R3. Okay, but let me just add it my own. You can say I1, I2, I3, R1, R2, R3. So look at these rays, 1 dash, 2 dash and 3 dash. 3 dash. Are they parallel? So this is called irregular reflection. Okay, or diffuse reflection. It can also be called as scattering because the light is scattered in all directions. Okay? But scattering is reserved generally for very, very small objects like dust particles. So here we are saying irregular or diffuse reflection. Is that clear?
Yes.
Okay. Irrespective of the surface, law of reflection is applicable at all kinds of surfaces. Like everywhere, the angle of reflection is equal to angle of incidence. Okay? So this is clear. Irrespective of the nature of the surface, law of reflection holds in all situations. Do you have any questions still here? Okay. Erase it. All right. Okay. Now let's understand about image types. Okay. So there are two types of images. See, when you're seeing yourself in a plane mirror, right? You see yourself in the mirror, right? So what kind of image is it? Is it virtual or real?
Virtual.
It's real image.
It's virtual.
Okay. How many of you for real and how many of you for virtual? Raise your hands. Real image. So everybody is for virtual. Okay. What is a virtual image and what is a real image? Yes. Yeah.
Virtual is the image where the light is being behind. Appear to be behind.
Appear to meet behind the mirror. Yes. Okay. Or else, huh? They do not meet because you have to explain in terms of reflected rays. Okay. So they appear to diverge from that point. That's what we say. We don't say they are meeting. We say they appear to diverge from a point after reflection. That point is where the virtual image is formed. A simpler definition would be it cannot be obtained on a screen. Okay, and real image can be obtained on the screen. So, can you see the image of my palm? So is it real or virtual? It's real because it is obtained on the screen. Can my image in the mirror be obtained on screen? Like when I see myself in the glass, I'm appearing, okay, I can see myself. If I keep a white screen behind the mirror, will I be seen on that screen? No. So this image is formed inside the mirror. But we say it is forming behind the mirror. That's what we say. Okay? All right. So there are two types of images. Real and virtual. Okay. So when we see things, what kind of image is formed? Real or virtual? Huh? Real. Because the light rays are entering into the eyes, but eye is a lens. So those things we will be studying after understanding what is refraction of light. Right now we are studying reflection. Okay, reflection and refraction is a separate. But then those images which form inside the eye are real. We'll understand that later. First, let us define what is real and virtual. So this image, this type of image is formed. So this is formed. When the light rays meet after reflection. Okay. Is formed at a point where this is more appropriate. Okay, real image कहाँ पे form होता है? This is formed at a point where the light rays meet after reflection. The word after reflection is very, very important. ठीक है? What about virtual image? This होना चाहिए, it होना चाहिए. English experts do the grammatical fix. Okay, it is formed at a point so I should here include meet also. Meet after it is formed at a point. What? Try. Okay, if it is wrong, you write it.
Behind the pillar where the light is appearing now.
Yes. So mirror. When we say mirror, we are fixing the surface. It could be any surface. Any kind of mirror, plane, curve, spherical, anything. Okay. So we will define it in terms of reflection of light. What will we say? It is formed at a point from where, yes, from where the light rays appear to diverge. Meet is also called converge. Okay, appear to diverge after. Right, so this is a general definition irrespective of what is the nature of surface. Yeah. So second point is real image is always inverted. Okay, it is always inverted. This definition is also true for refraction, reflection or refraction. But we will write it again just by changing this word. So keep this definition in mind. The term reflection will be replaced by refraction later on. Second, it is always erect or upright. Always erect or upright. So it can be obtained on screen, physical screen. Okay, this cannot be on screen. Okay, so now let us understand rough diagram of. We will do plenty of diagrams. Let us come to reflection of light by curved mirrors. Okay, we are going to do that. Let us understand reflection of images by plane mirror first. Okay. First, focus on these definitions. Is it understood? So now let us see image formation by plane mirror. Plane. So let's take an example of English alphabet E. This is the object kept in front of the mirror. How will you see it in the mirror? It will be turned by 180 degree. So let us say this is the distance from here. So it will be obtained at the same distance and laterally inverted. What is it called? Laterally inverted. So what are the properties of images found in a plane mirror? First is, yes, it is virtual, direct,
of the same size.
yes, of same size. So this is called nature of image, virtual and direct. And size is same size. What else? Laterally inverted. Laterally. Is it double L or single L? Inverted. Single. Huh? Double. Inverted. Yes. And this distance is x centimeter. This also will be x centimeter. Same distance. So these are the properties of images. Image property. Image is virtual and direct. Image is same size. Image is laterally inverted. Okay, all these are related to the image of this. This is the object. This is the image. All of this is property of this.
Image.
Why?
Because it is
Virtual. Very good. Good point. So image should be dotted. ठीक है? So laterally inverted का meaning क्या होता है? Flipped by 180 degree. in flipped around vertical axis. है ना? कहाँ पे inversion हो रहा है? Horizontal plane में, but axis क्या है? Vertical. ठीक है? So now if this is the axis, then it is flipped like this, 180 degree. So plane is horizontal, axis is vertical. Okay, either which way you can. So in horizontal plane. So this is how the image formation is taking place. This is virtual, the one in the mirror. Where is the image? Same distance. Behind the mirror. As the object in front of it. Okay, so these are the properties. So any struggle in understanding all these 4 points? Anybody? All good?
Yes.
Take some time. Online students, all okay?
Yes.
I'll ask you questions. Okay. So let us say this is 10 meters. So what is the distance of image from the object?
20 meter.
20 meter. What was the question? What is the distance of image from the object? 20. This is what silly mistake happens. So depends. What is the reference? Okay. So read the question carefully. Right. Now second question. Let us say this object is approaching mirror with the velocity 5 meter per second. Okay. With what velocity the image is approaching the object? Huh? Same speed, because image is also running with 5 meter per second with respect to the mirror. Mirror is stationary. But what about the speed with respect to the object? So one car is traveling, let's say 5 meter in this direction, the other car is traveling with 5 meter in the opposite direction. So what is the relative speed? They will get added 10 meter per second, isn't it? So again, you have to be careful about how the question is asked. If the object is running in front of the mirror with 5 meter per second, right? Object, but with what speed the image will run with respect to the observer? Mirror is not going to measure the speed of the image. Who is measuring the speed? Observer. So observer will feel that the image is running at double the speed, because when he is observing, okay, the speed of the image with respect to the observer, both are running towards each other, right? So the speed will get added. Isn't it? Yes. Now, see, it's like it is relative speed, right? So both objects are, let us say, both cars are running in same direction. So what is the speed of one car with respect to other?
0 meter per second.
0, because when you look at the left side, the car is always in your side. So there is no speed with respect to each other, because they are traveling in the same direction. Now reverse the situation. Same speed, but they are traveling in opposite direction. Now it will be added. In the first case, it got subtracted. Now added. Okay. So these answers are very simple if you have got the logic. So these are what? Relative speeds with respect to observer. Okay. Okay. So let's proceed further. What is the next topic? By curved surface, right? Next of light. By curved surfaces. Okay, so before going here, I think here I forgot to tell you what is the speed of light. So everybody knows this. Speed of light is v into h. So its symbol is c. 3 into 10 raised to 8 meter per second. In what medium? So it is solid space or vacuum or air. Air, it is slightly less. Air means atmosphere. Slightly less, but almost same. Okay. In any other medium, speed of light will be less. Okay. So what are the other mediums in which light can travel? Water, glass. So there are different types of mediums. So air is one. Air or space is one. Then you have glass. You have water. Okay. So depending upon how the light can transmit through it, you have 3 different types of surfaces: opaque, transparent, and translucent. You know the difference? SCEAT or CEAT? Lucent, translucent is C antenna. So who will tell me the difference between opaque, transparent, and translucent with example? Opaque is this wall. If you can't see anything behind the wall, that means this is opaque. No light is passing through it. You can only see things when light, reflected light is reaching it. So no light is crossing the wall. So this is opaque. Cable is opaque. Right? Transparent is glass window. You can see everything behind the window. Okay, so that is transparent. What is translucent? So you can't clearly make it. You have rough idea about there is an object. This is translucent. So you can observe the movement, but you can't clearly see who is who. Clear? So all three examples are understood. So when the light passes across the medium, it is called transmission. Okay, when it is bounced back, it is called reflection. And when it is transmitting, it suffers something called as refraction. What is refraction? The direction of light changes in the other medium. Whenever light passes from one medium, one transparent medium, to the other transparent medium, its direction changes. Okay, so during transmission, light suffers refraction. Okay, so we'll study about it in more detail, but let us finish reflection of light by curved surface. So we are going to study about two types of curved surfaces. Class is till 6:20. So curved surfaces are two types. Concave mirror. So again, first we studied plane mirror. Now we have concave mirror and convex mirror. Okay. So what is a concave mirror? Concave mirror is something like this. The reflecting surface is curved inwards and the silver coating is outwards. So reflecting surface is coated, reflecting surface is curved inwards. Right. How is concave mirror made? It is a part of hollow sphere, right? So suppose you had a sphere, right? So the sphere will look something like this. Right. So once this part is cut, okay, so it will be like a dish. Okay, so when the reflecting surface is curved inside, then it is called concave mirror. Now if you cut the mirror from this side and silver coating is inside, now the reflecting surface is curved outwards. Then it is convex mirror. So how is convex mirror? Convex mirror will appear like this. This is your convex mirror. So how do you define? Just say reflecting surface is curved outwards. Is curved outwards. Okay. So let us quickly understand few terms associated with curved mirrors before understanding the reflection of light, but that will happen in the next class, I think. So obviously the sphere will have a center. Then this mirror will have a geometrical center, okay, which is called as hole. So first is some terms associated with curved mirrors. The first is center of curvature. Symbol is C. So what is center of curvature? Center of the sphere from which the mirror is cut. Center of hollow sphere from which the mirror is cut. What is P? O. It is the geometric center of the mirror. I mean, mirror is a surface only. Okay? So it is a hollow sphere, no? So it is a surface only, curved surface. It is the, what did I say? Geometric center. Because it is an object, right? So an object can have one center. You mean to say there could be confusion like if this plane, center of this plane. That way, right? Okay, ठीक है, चलो. So it is the geometric center of the surface of the mirror. ठीक है. What else? So pole will lie over here, not this center of the diameter of the mirror. Okay. Now, what is this diameter of the edge of the mirror called? It is called aperture. Okay. What is aperture? Aperture is URE or ERE? URE. Okay. So aperture is, if I give the name AB. Okay. So AB is the aperture. It is. So what does it mean? The light, incident light, okay, cannot be more than the aperture. Okay, so it is the exposure, aperture, less aperture. Suppose the glass has only this much aperture. Light will be incident only through that aperture. So it is the window which allows how much portion of the mirror will be exposed. Okay, so it is the horizontal thing, right? So it is the diameter of the outer edge of the mirror on which through which the incident light falls on the mirror. So aperture sometimes becomes very confusing to understand. So this is what it is. So incident light will fall through the aperture. Okay. Then what? Then you have principal axis. So what is principal axis? CP. Yeah. So line joining C and P. Okay. Okay, this is the principal axis. Then you have focus. What is focus? Let me draw the mirror over here. This is P, this is C. So this is your principal axis. Okay. It can extend on both sides. So focus is the midpoint of C and P. So its symbol is F. So basically the how focus is defined. So if any incident ray which is parallel to principal axis after reflection, right? It will pass through focus. So focus is the point on the principal axis, okay, through which the incident parallel ray to principal axis passes after reflection. Okay, and how do you draw a reflected ray? You need a normal. What is the normal at this point? Radius. Radius will always be from center to that point on the surface of mirror. So this is your angle of incidence. Now construct equal angle of reflection. So I and R will be bound to the same. Okay. So what is F? It is the point on the principal axis through which the parallel incident ray passes after reflection. So you don't have to mug it up. If you understand, you'll be able to write it. Okay. So I'm not writing it ever. Should I write it? You are anyway not writing it. Okay. So this is your focus. And what is the relation between this? So CP, the symbol of CP is R. This distance, it is called radius of curvature. So R is called radius of curvature, and this distance F from P is called focal length. Okay, this is defined. This is symbolized as small f. And there is a relation. So F is equal to R by. Can be proved also, but proof is not there in your scope. So there is a relation between radius of curvature and focal length. What is F? Focal length. R is radius of curvature. Okay. So in the next class, there are two more distances left. Image, distance of image, distance of object, and we'll learn about the sign convention. When these distances are taken as positive, when are they taken as negative? And there is size of object and size of image. Okay. So that will be covered under sign convention, etc. So we'll stop here today. Any questions before I leave? You have any questions? So we'll cover it in the next class. All right. Thank you.